so much better than trivia. Alright. Good? Hi everyone, welcome to week 5 with UQCS. It's great to see all of you guys here. We did take a break last week, so yeah, we're back hitting the ground running today. So tonight we do have a very special guest with us. We have Dr. Joel Fenwick, who to some of you guys, you'll probably know that he used to coordinate CSSE 2310. To others, you probably don't know that, so now you do know that, like myself. And yeah, so obviously today he'll be giving us a really good talk on, I guess, Rust. And yeah, I'll leave it to Dr. Joel to take it away from here.
Thank you. So yeah, I'm a former lecturer, current programmer, life member of the society, and the butcher of 2310. So that's presumably, but here I'm not here to talk about that. I like programming, and I'm a C++ programmer by inclination and training, but I thought, well, I like talking about programming, I like other people talking about programming, but I want there to be some variety in that. Like, here's a new language and here's a tutorial is fine, but I'd like some variety. You can't tell what a language is like by learning how to write a Fibonacci function or something, right? That doesn't tell you how the language works. So I'm trying a little bit different. I'll talk about why I hope this talk will be interesting, no promises. I'll tell you about the program I ported in order to try and learn a bit about Rust. I didn't start from absolutely nothing, I had a book, but I wanted to learn by porting. I'll talk about some of the tools and then we'll sort of flow into what I experienced when I tried to do this, and we'll summarise at the end. Questions either as you see fit or at the end. I can kind of cope with both, but let's see how we go. So why? Programming language is interesting, as I've already said. The other thing is, maybe if you have a background that resembles C++, that kind of object-oriented derived from C, so maybe C++, maybe Objective-C, sort of. What might trip you up when you try to use Rust, not because Rust is flawed, but because of what your previous preconceptions do to you, what mismatches. I also wanted to give you a little bit of a taste of what an experienced programmer might do when confronted with this, because this is something that we don't get to do in lectures. We spend so much time that we try to get the basics through that elements of aesthetics and taste and judgment don't get as much attention as we would like. And finally, Schadenfreude. You may have been suffering under the hands of programming teachers, and the idea of seeing one waddling around in distress might bring you some perverse joy. So let's see how we go. Note, this is not a serious comparison or critique of either language. If you really like either language, don't feel the need to jump to its defense because I was doing it wrong. That's kind of the point of this talk. It is not anything near best practice. You can look at my GitHub, the project is called Decker, and the current release has both a C++ implementation and my Rust implementation in it. So you can look at these things and get some understanding of how not to do things. And it is certainly not a tutorial. So don't look at this and go, but I don't understand how to program Rust at all. Not what I'm trying to do. So, the program. The program is about a game, so I need to talk about the game. The game is Dominion. It's a tabletop card game. It popularised, if not started, the genre of deck building. No, Magic the Gathering is not a deck building game. Comes with roughly 25 card types, and each game you pick a subset of 10 to play with. Okay, not too hard to do, but this is a modern board game, and modern board games have expansions. Lots of them. So, for example, the UQ Games Club, their collection has 186 card types in it, and their collection is nowhere near complete. So when you do that, how do you pick these subsets to play with? You kind of like the subsets to have some sort of synergy in them. So I wrote this program, Deca, to generate markets, these subsets, meeting some constraints. The cards have to have some form of synergy. This is, if you like, a very stupid constraint solver. Right? If that's how you think about things. So, the C++ implementation, oh look, there's lots of options. That's kind of what you need to get. There's all sorts of constraints you can put on this. The ones of interest here are bad random, which turns on the bad random number generator. Why do I do that? Because lots of languages have very good random number generators, but they're not consistent. Right? If I use C++'s Mersenne twister, that's great, but if I port to Java, how on earth am I going to get exactly the same random sequence? So I built a bad random number generator.
Doesn't Java have MT19937 or not?
It might, but then I just cheat and go and Python, and COBOL, and whatever. You can also specify the seed. This is kind of important because I want repeatability in my program. I want to be able to test it. Ideally, I want any new implementation to be able to produce exactly the same output for every single input. So I need repeatability. And I can also ask why, which will get the program to tell me why it thought it was a good idea to put that particular card in. So I run it, and look, it's telling me from these sets, pick out these cards. This will mean something to some of you and very little to the rest of you. That's fine. Program run. Program produce output. There's some more. Let's bad random and with this specific seed and from the seaside set. Y general is just, hey, I picked some cards at random. But it's added in Lighthouse because there's an attack card and Salvager because there's a cursor card. Okay, so constraint satisfaction. I'm achieving a lot. In the C++ code base, there are 55 classes, 3 structs, and in terms of inheritance, cost target is an abstract that has 3 subclasses, constraint action has 6 subclasses, and property has 20, including at least one that uses multiple inheritance. Okay? This is not very clever stuff, okay? This is the code I wrote. And according to Clock, line of code counting tool, it's got just under 4,000 lines of non-trivial C++. Okay, so professionally, a pretty tiny program. But it's big enough, it's got files, it's got string manipulation, it's got data structures, enough that it's going to be worth porting. Okay, so I'm going to start trying to port this to Rust. I've got the program working in C++, I've done some debugging. In terms of code interaction, I just used Vim or Kate. Plain text editor works fine. I chose not to use any non-standard crates or cargo. Now the reason for that was because I wanted to control and understand every aspect of the program. If I can hand off large chunks of the program to somebody else, I'm not learning anything. But also, if that has weird behavior, I won't be able to replicate it in another language. Yo.
Did you use standard libraries, STL classes in your C++?
Yes, I used the STL in the C++ program, and I used the Rust standard crates in there, but I didn't go off on the cargo, I didn't import anyone else's code. It's kind of, the language as it comes was sort of what I was aiming for. So no, I didn't do it without crates entirely, just weird ones. For debugging, didn't need a symbolic debugger that much. Print debugging works pretty well, but GDB works well enough. I already knew that one, so I used it. First thing for people who are used to C and C++, in C++ and C, quite often you're debugging for a program, you stop somewhere, okay, what would that line output? P, copy and paste that line. You can call functions, you can do all kinds of stuff, right? In Rust, that works some of the time, but other times you copy and paste some code and it goes, no, I don't know about that method. The reason for that is because the methods are a couple of levels down in Rust's auto-dereferencing behavior, and the Rust compiler knows how to deal with that, but GDB doesn't. But if you're used to C, that's going to cause you a few problems. Rust C works fine from the shell, so I used it, and I used Rust C 1.48 from Debian 11. But that's not the latest Rust, no, but it is the one that's available in Debian. That's actually a point, because I want to experience what Rust has, not if you were truly committed, you would have compiled them nightly. That's not, again, the point of the talk. So, interacting with the compiler itself. Well, there are those of you who feel, who's done, what is it, 2010 or 2310? Right, okay, so you've interacted with a C compiler, or a C++ compiler, something like that. And you might feel that the compiler hates you because you hand it your hard work, and all it does is just criticize, page after page after page of criticisms, things that it's found wrong with your program. C is at least direct. Rust likes to toy with you. Okay, so this is a real error with all of the useful stuff stripped out, okay? Rust C main Rust. Aborting due to 4 previous errors. Well, we're doing well. I've got my errors down, right? I'm going to fix one of those errors. Aborting due to 218 previous errors. Now, before some of you ask the question, yes, sometimes in programming when we fix one problem, that uncovers a problem later on, and actually that problem was there all the time, but the compiler couldn't see it because we'd hidden it by what we'd done. My complaint here is that this error, for the Rust people, had absolutely nothing to do with the 4 problems it showed me before. It wanted me to feel like I was making progress. I wasn't, but it just didn't want me to be too upset about all the errors, so it hid them from me. This took a bit of getting used to. I'm used to errors being generally monotonic. Oh, the error count's getting low. The program doesn't work. Still got to test it, right? But I'm nearly done. No. Okay, testing. Because this is command line tool, and because it outputs from standard out and reads to standard out and reads to files, if you've got shell scripting, and you should have shell scripting, use it. So all I've done here is, here's a bunch of seeds, iterate over them, save the output for my C and my C++ and Rust implementations, diff them, and see if they're any different. And I can do bulk testing here. This test runs pretty quickly, but I can run a much larger range of seeds. This is brilliant. If you've got a working implementation of the program you're supposed to be writing, you can compare against the other one. File interaction. This was pretty simple in my program, and there's nothing to report. The traditional loop of read a line of text, process line of text, read line and next line of text works fine in Rust. I didn't have any problems. So, classes. Rust doesn't have those, and I had 55 of them. So, because this issue sometimes comes up when people think about OO design, and there's either OO is great and if your language doesn't have it, I can't use it, or OO is fluff and real languages don't have that, keep that away from me. Both these sides are wrong. The big question is, okay, how much inheritance, how much code inheritance are you actually using? Because I don't want to completely restructure my program. Are we just using a selectable function that carries some state? Okay, what on earth does that mean? Basically, depending on what type of thing you are, call that function, or that function. Right? That's all I want to do, and maybe I want to remember something while I'm doing it. Does it look like we can do function pointers or put functions into variables? Yes. Then we can probably simulate what we need. You can simulate a lot of OO stuff in C just with structs and function pointers. So I think I can probably do it in this language I don't know. So Rust has struts. They're more like C++ struts though, in that you can put methods on them. And they have this thing of traits. Okay, that sounds like it can do interface conformance, interface compliance. Like, these are different things, but all of them can do stuff, get stuff, and die. I don't know. So good, that sounds good. This is not done by subtyping. This becomes important later. Okay. Now, it turned out that there was a little bit of, a lot of these subclasses had common members. There were a few members that were common to all of them, and I initialized those in the base class. So I had to get around that. But, you know, that's workable. Next thing. Next thing. Smart pointers. Okay, what's a smart pointer? For the C++ challenged people, it's like a pointer that cleans itself up when nobody's using it. They're great. Rust has them, but in Rust you tend to need to build things up from components. Right? They don't go, here's a thing and it does everything you want. It's more like here's a collection of things, stitch them together. So this is a single thing that is one of these cost target things. Remember there are like 20 of these. Inside a box which puts it on the heap instead of the stack. And then I want a reference count. So that's, you ended up having to do that. So, problem number one. I've got a set of cost target objects. Well, I've got a collection of cost target objects and I don't want duplicates. If there are 7 cards, all wanting something costs 2, I just want one constraint. Okay, so normally in programming you'd go, hey, sets stop you from having duplicates, let's put it in a set. Technical stuff here. The version of Rust that I'm using needs the trait or the object to have the comparison method on it. It does not allow external comparison functions. External comparison functions would have made this real easy, but it didn't have those. Also, Rust won't let you add methods to smart pointers, and I wanted to deal with everything through smart pointers. So, first lesson here, hold on. If this doesn't work, I can just make a vector, and I can just, whenever I want to insert something, go through and check to see whether there's anything already in there. That gives me set functionality. Now, as computer scientists, you should be seeing order n insert and throwing up a little, but it will work. And if I get this working, I can write the rest of my program, and then maybe come back and learn how to do this. This, being a problem, doesn't sync my whole program. I may just put it in a little isolated thing and do that. Okay, I can live with that for now. So, I've got these different types of things. They all follow the same trait. And I want to compare these things, but I don't know how to. Because in Java what you do is you write, are these two things the same type? No, they're not the same. Yes, cast them to the same type and compare all the members. Casting down in Rust, going from the generic to the specific, is possible but not easy or automatic. So, I could add a string representation function to the trait. And then, if you were formatting an order and insert, get ready, I could ask each of these objects what their string is, and if they have the same string, they're the same object. Or they have the same state, I should say, not the same object, same state. Again, I'm not proud, but it'll work. I already wrote one of those for debugging. Thanks, Past Joel. This is great. In the back of my mind, but this wasn't designed for this purpose. This is just debugging. Are we sure this is safe? It will probably be fine. It wasn't fine. There was one Boolean variable in the class that I never printed out in debugging because I never needed it. And so that never became part of the comparison. And I only found it when I did my bulk testing and found that some of the Rust seeds didn't work. Yes?
Did you use the derive proc macros when you were doing these, or did you implement them by hand? Because you mentioned comparison was automatic, but if you do derive comparison, it will do all that for you. I wasn't sure if you'd use that.
I had a look at it, and I think I stumbled down a hole and got stuck.
Okay, because also like proc macro derive display would do the representation for you.
Yeah. That one I didn't think of. I think I got very, it all got very twisted because I was trying to do everything through smart pointers. And that meant that the things I define on the object don't exist. I'm convinced smart pointers weren't actually necessary, but I couldn't get it to work without them, so that's what I did. For the Rust people to laugh at, this is what I actually ended up doing. I had a struct that had the state variables in it. I had the real type that was a reference counter pointer to the struct, and then all of the methods were defined on this thing, referencing into the box. Those of you who don't know Rust, don't worry about it. Amateur did stupid thing, is probably about the lesson. Problem 2, strings. What do you get when you cut into a string? Well, C++, here's a string, let's cut into it, and the thing we get is assignable to a char. Java, very, very similar except for the casing on one of the classes. Python, of course, has to be different because Python be Python.
Well, it doesn't have a character type.
It could if it tried hard. It's decided not to out of spite, I believe. When your ORD function, the thing that converts a character into its numeric code, takes a string and then goes, yeah, but you probably shouldn't call it with longer strings. Yeah. So we've run into ASCII and Unicode here. So ASCII, 8-bit encoding, Unicode, bigger encoding. Which encoding is your Unicode? Well, let's not talk about that. Let's use the system default and hope that the document originated on your system. Ever opened a thing from another system on your Python and found out that the encoding's different? Fun. So in C++, they did this by going string and wide string. ASCII, Unicode. And these store chars and wchars. Python 2 used str and Unicode. Python 3, they went, no, that's not actually what happened at all. What happened was the str was always Unicode, or it is now, and bytes is kind of like a string, but has decode on it. Okay, Java, well, strings were always Unicode, and chars are always Unicode chars. There's a problem with this. Chars might not actually exist. Okay, this is a problem in Unicode. There might not be such a thing as a character. So, that kind of ruins all this. So in Rust, all strings are Unicode, but they are explicitly UTF-8, which means the Unicode values, I'm going to say, can vary in size, which means you can't know in constant time where a particular character is in a string. So all values the same size, and indexing into a string is by byte, not by char, or value, which means you pick a number and it might be in the middle of a Unicode character. That's bad. You shouldn't do that. Why does that matter? Because I knew all of this going in. The problem, and this is something that we often see in novice programmers, and we hope that as people get more experience, they become less vulnerable to this. But all of us get caught eventually. I wanted to do some string manipulation to take a substring out, and I knew that this was tricky, and I knew that characters could be different sizes, and so I wrote this code, and I can't remember whether it had 2 loops or it was just 1 loop with 2 indexes walking through the thing to keep track of where the chars were. There was a very simple solution, but I couldn't see it because I was keyed up for Unicode complicated. And it's not that I couldn't get my complicated code working, it's that it was unnecessary. All I needed to do was call the how big is this char method. That was it. But I worked real hard and found all the corner cases that I didn't need to. Okay, there's also in Rust a distinction between a str and a string, and I'm not getting into it. You don't need to know for the purpose of this talk. Okay, next problem. This is sort of a grab bag. Linguistic interference. So what linguistic interference means in this context is not that you don't know a language. You know multiple languages and you pick the wrong one. So, let's suppose that you have a type that can store a number of different things like an int and a string. Not at the same time, just one or the other. A union of the possibilities, if you will. What would you call that? Of course you'd call it an enum. This is my problem, I'll deal with it. It just bugs me, right? Union is a perfectly reasonable thing. They have tag discriminated unions and Rust went, no, we're calling it an enum. More practically, there are, I think this is the three that are used most in the standard libraries, option, result, and entry. And all of them have two possible values, and all of them have different names, and I always get them wrong. I think I'm looking at an entry and trying to find OK or something and wondering why that didn't work. That was a bit confusing. So that's just a learning problem, right? That's a skill issue, I guess. Right? That's not really a flaw in the language. It's just I ran into that problem, okay? Other linguistic interference, slicing. So here's the Rust syntax and the Pascal syntax for indicating ranges. If you've done a compiler course, you might see this sort of syntax because for some reason compiler teachers love Pascal. And this is the Python slice. I sat there at work with my Python script, with the little arrow pointing at this for 5 minutes, pushing it occasionally to rerun it to see if it had changed its mind. Unable to understand why it couldn't comprehend my perfectly reasonable slice. Okay? Sometimes it happens. This one was bad for me. This is the Rust generic syntax. This is the C++ template syntax. They just did it to spite us, I think. They took so much from our language and they couldn't get this right. Loops, again, stuff's up. This one is fun, substrings. In Rust, you indicate start byte and end byte. In C++, substrings, you indicate start and length. Okay? Mysteriously, a whole bunch of my card names were getting truncated and I really couldn't understand why. And there's nothing here in the syntax that indicates that to you. There's nothing that makes you go, oh, well, of course I got that wrong. You just got to make sure that your head's in the right space. Rust type inference versus C++ auto. So C++ has a keyword that you can put instead of a type declaration, and you can say auto this, compiler, you can look at the expression and you can work out what the type is, and if you're involved in templates in C++, the type is probably about that long, so you work it out, you know what it is. Rust, you don't need to specify the type of a variable all the time. We'll kind of look at the code and get a feel for what it thinks it is. That looks similar but works very differently. Not just the underlying mechanism, but the impact. So, I'm going to talk in C for a minute. So you write some C and you compile it, and it compiles just fine. And you add some more C, that compiles. And then you add a third bit, and the compiler goes, no, that bit's wrong, that bit contradicts, that bit's not good. In Rust, you can write your first bit, and it compiles, and you write your second bit, and it compiles, and you add your third bit, and in Rust goes, the first bit's wrong. It's like it was okay before. Now what's actually happening is that Rust is detecting a contradiction with the new code that you introduced, but it's very disconcerting for it suddenly deciding it didn't like that bit of code. Rust and C++ both have discretionary constantness. That is, you can say there's two lists and one of them can be changed and one of them can't. C++ only cares if you don't change it. Rust cares how many things are looking at it. This does lead to some situations where I got tripped up because, like, why isn't this? This should be fine. The other fun one is that you can have a mutable thing inside a constant box. And the compiler kept going, that thing shouldn't be constant. It's like, but I want it to not change. That's a bit, from a C++ point of view, if you have a constant container, you don't change anything in the container. Just interesting, Rust defaults to move for complex objects rather than copy. So it's not like Python where you go A equals B and then now looking at the same thing. And it's not C with struts where A equals B and now they're copies of each other. A is assigned B means B doesn't have the value anymore. Get that? Now C++ has moved semantics, but they're not by default. Like you can add it to types, but it will still try and fake it with a copy and a destroy if you don't have that move constructor. Yes?
I thought it might be because no one wants to type in double ampersand against everything.
No, you don't need to do that most of the time. Using enums to get rid of null pointers, that's kind of a cool idea. A little bit frustrating sometimes. You go, okay, if this is null, if this is none, I think go over here, otherwise run the code, and you've got your variable, and you know it's not none, and you try and get something out of it, and it goes, you haven't checked if it's none. But yeah, I did up there. Yeah, but I don't remember that. So a reflection on the approach. How is this for learning? Forget about professional software development for a minute. How is this for learning? This is no substitute for disciplined study, but I didn't expect it to be. It is probably a quicker way to run into corners though. If you follow a disciplined curriculum, a book, VSUs, whatever, then you're going to learn the concepts, they're going to make sure you understand the concepts, you're going to move on, but you're probably not going to find the difficult bits. Like think of high school maths. How many of you worked out, hold on, isn't it a bit strange that in all the quadratic equations we're solving, the discriminant is negative, never negative? Right? You don't give people those problems, you steer them away from the problems you don't want them to think about because learning's hard enough already, right? But if you're porting this, you'll very quickly run into things like how on earth do you define a hash function on a thing that doesn't want one? You run into those problems, you find out what the language makes difficult, or at least doesn't expose very well. You can focus on translating a small thing at a time, so you can build up, and you can do bulk testing. This is really good. It's not often that you're in a position where you're actually able to do that, because if you already had the program, why are you writing the new one? But I guess if you're trying to code a complete replacement, that might be an idea. I didn't find any Rust unique insights. So sometimes when I hear stories about Rust, it goes something like this. We had this driver code in production, and it was in production for however long, and then we ported it to Rust, and Rust showed us all these race conditions that we were possibly vulnerable to. You know, now we know that that's a problem. I didn't find any of those, but I've got no concurrency in my program, okay? Rust is not going to work wonders there. It did remind me how awful C and C++'s unsigned integer input handling is. I want to, what is it, you guys see? scanf percent %u. Okay, if I enter -500, that won't work, right? No, it'll work just fine. That's really stupid. For shallow mistakes, and by shallow mistakes I mean a mistake that if you fix something on one line, the error's gone, right? For that, where Rust makes suggestions, well, I didn't see how far back this was, further than I hoped. There we go. Rust will sometimes make suggestions like, hang on, I expected this but found this. You could try doing that. Okay, so that's going to sound, oops, that's going to sound really good. Hey, I don't even need to know what's going on. I just get the compiler to tell me how to fix my program. Yeah, I should have practiced that bit. Oh well. Note that Beamer does generate all these accelerators down the bottom. and I'm not going over to the keyboard to use them. Okay. But you can end up with this situation. Rust, A is wrong, you should write B. Okay? B is wrong. And even in rare circumstances, B is wrong, you should write A. So you have to understand what it's actually suggesting and understand whether that's a really good idea or not. Okay? Auto dereferencing makes it very difficult to do things with actual pointers. Auto dereference can put the compiler into a state where it can't decide where something is. Like I try and call a method and it's inside an RC, inside a box. It's, you know, that one. I want to call a method in there. And sometimes it works, and sometimes the compiler goes, I can't work out what it is. Could I tell you? No, that's a nightly feature and you shouldn't use it. Bear in mind that may well have been fixed in the major release version by the time we get here. What I'm talking about is inline type specifiers. The version of Rust that I used declared that a nightly feature and it couldn't be trusted yet. So that created some fun problems. Also, understanding that if you borrow out of an RC, that holds the door open. It took me a while to realise that. From a C++ programmer's point of view, C++ programmers should be used to wrapper types. We use smart pointers all the time. So this should be fine. Things of value existing on the stack. Okay? Now this is a heresy almost for the Python and Java programmers. Java will at least tolerate integers maybe living on the stack, but objects can only exist on the heap. It is the law, apparently. C has no problem with it, C++ has no problem with it, and Rust has no problem with it. Okay, finally, strictness on types. Beyond Strut, the C++ creator has commented recently that he thinks that C++ is a little bit forgiving in terms of what it allows to auto-convert. He thinks he should have been a bit stricter with that. But, and I understand from an implementation point of view why this is true, but really, what 4-bit processes is Rust running on? For those of you who don't follow this, that's fine. U8 is an unsigned 8-bit integer, and I'm not allowed to pass one of those into a vector lookup, because vector lookups need to use size, which is unsigned word size. So 32-bit, 64-bit. And the Rust compiler wanted to insist that I properly convert an 8-bit number to a 32-bit number, and specify what I would do if there was an overflow. Okay? As I said, what 4-bit processes is Rust running on? I know why they did it, okay? I do understand that, but it's just a little bit like, really? You think this is going to overflow? Fine, I will not use small integers for any variable in my programming. 64-bit integers everywhere. What's that? You want to be an embedded language too? Huh. Sarcasm is good. Thank you.